morning students, I hope you all are doing great. This is Pooja and you are watching my channel Jigyasa. Today I will be covering the third chapter of class 12 physics, that is current electricity, and this is lecture number 1. What do you mean by current? If I take this as a conductor, now if I cut this conductor normally, I'll get this kind of a circular surfaces known as cross section of the wire. So number of charges flowing through this cross section of the wire in unit time is known as current. So in mathematical form, I can write current as charge divided by time. Unit of current is ampere. For the production of current, only negative charged electrons are responsible. Positive charged proton cannot move as they are 1837 times heavier than electron. But we often say positive charges are moving because when electrons move, it gives us the visualization that positive charges are also moving in the opposite direction. Current's direction is always opposite to the flow of electrons, or current's direction is always in the direction of flow of positive charges. We can see only when the key is closed, the bulb glows. That means only when the key is closed, the electrons get a continuous path to flow from the negative terminal of the battery to the positive terminal of the battery. Thus, we can conclude current always flow in a closed circuit. Average current means when we are taking the average of the current flowing between short interval of time. I average equal to delta Q by delta T. Delta Q means Q2 minus Q1 and delta T equal to T2 minus T1. Whereas instantaneous current is the current taken at any instant of time. I instantaneous equal to dq by dt. To make it more clear, let us see these in the graphical form. Let the values of a variable current noted during experiment is plotted on a graph. Join the points to get a continuous curved line. Now if I ask you what is the charge at 5 seconds, the answer will be 5 coulomb. So the instantaneous current at 5 seconds equal to dq by dt. This is dq and this is dt, that is 5 divided by 5 equal to 1 ampere. Now if I ask what is the average value of current flowing between t equal to 3 to t equal to 5, the answer will be I average equal to delta q by delta t. Delta q means q2 minus q1 and delta t means t2 minus t1. Here q2 is the final charge, q1 is the initial charge, t2 is the final time and t1 is the initial time. So the value of average current equal to 5 minus 4 divided by 5 minus 3, that is 0.5 ampere. Till here I hope you got a brief idea about the instantaneous and average current. But what will you do if the current is given by an equation? Let us understand this by numericals. A current flowing through a wire depends on time as I equal to 3t square plus 2t plus 5. The charge flowing through the cross section of the wire in time number 1 from t equal to 0 to 2 seconds and number 2 at 5 seconds. Here the current that we have to find in number 1, that is from t equal to 0 to t equal to 2 seconds, is the average current, and number 2 at 5 seconds we have to find the instantaneous current. Now let us see the solution for number 1, that is from t equal to 0 to t equal to 2. Given I equal to 3t square plus 2t plus 5. Here I is a variable current, that's why the current I is given by an equation. Here we have to find average current because here there is an interval of time for which you have to find the current. Average current equal to delta q by delta t. Delta q means q2 minus q1 and delta t means t2 minus t1. Here q2 is the final charge, q1 is the initial charge, that is at t equal to 0 second, t2 is the final time, t1 is the initial time. So now we have to find charge at 2 second. So put the value of t, that is 2, in the equation of the current, that is 2 square plus 2 into 2 plus 5, that is 21 coulomb. The same thing you have to do for the charge at 0 second, that is 5 coulomb. Now put the values of both the charges, that is final charge and the initial charge, divided by the final time minus initial time, then you will get the value of average current, that is 8 ampere. Now let us find the instantaneous current at 5 seconds. Instantaneous current equal to dq by dt. dq means small change in charge and dt is the small change in time. Here actually we have to do differentiation of q with respect to t. So ddt of the variable current, that is 3t square plus 2t plus 5. Before doing this, we have to know the basic differentiation, that is d dx of x to the power n equal to n x to the power n minus 1. So let us come to our main equation, that is 3 is constant here, so 3 will come out, and t to the power 2 means 2 will come out, 2t to the power 2 minus 1 plus 2 is constant, it will come out, and dt by dt plus 5 is constant, so differentiation of any constant value is 0. dt by dt, the value is 1, so can be cancelled out. So we got 6t plus 2. Now put the value of t, that is 5, then we got 32 ampere. This is the instantaneous current. There is one doubt which every student might have. Current has magnitude and direction. Then is current a vector quantity or a scalar quantity? To understand this, let us take two currents, current A and current B, flowing through a wire by making theta angle with the x-axis. Let me elongate these two currents. If it were a vector, we would have got cos theta terms in the resultant. But the resultant that we are getting is simply the addition of these two currents. That is 5 ampere plus 3 ampere equal to 8 ampere. Current does not follow vector law of addition. Current adds up like a scalar quantity. Thus, current is a scalar quantity. Studying is incomplete till you can solve numericals by your own. That is why here is one numerical for you to solve. Give the answer in the comment section. To continue with the lecture, watch lecture number 2.